Hello students, today we will discuss the different types of coordinate system. All of you know the Cartesian coordinate system to specify one particle's position. That means in Cartesian coordinate we require x, y and z in 3 dimensions. So today we will discuss some other types of coordinate system. So first we will discuss polar coordinates. So it is a two-dimensional coordinate system that describe a point on a plane by its distance from a reference point, that is from pole or origin, and it is its angle from the reference direction. That means suppose, so this xy is the Cartesian coordinate, and here a particle p, that is in Cartesian coordinate its position is vector is xy position. And if we draw a circle based on these p, so this is the op, o is the origin, op distance is the r position vector, and the angle between this reference direction and this r vector, that is theta. So in the polar coordinates, so polar coordinates is a two-dimensional coordinate and its position vectors are r, theta. So here we will see that what is the relation between r and theta with the Cartesian coordinate x and y. So if we draw a perpendicular projection in the x and y direction, so rx is equal to r cos theta and y is equal to r sin theta, where theta is this angle. So x square plus y square is equal to r square. So this is the equation of circle, x square plus y square is equal to r square and tan theta is equal to y by x. So the relation between the r theta using x and y is x square plus y square is equal to r square and tan theta is equal to y by x. So this is called polar coordinates. Now the next we will discuss, that is cylindrical coordinates. So this is a natural extension of polar coordinates in 3D space, that means 3-dimensional space. So these coordinates combine the z coordinate of a Cartesian coordinates with the polar coordinates in the xy plane. So this xy plane is the polar coordinate, that means it is a circle, and the upper surface is also the polar coordinates, and this height is equal to the z coordinate of the Cartesian coordinates. So suppose here p is the particle here. So for x, y, z Cartesian coordinates, this the position is x, y, z, and for cylindrical coordinates position vectors is r, theta and z. So r theta is equal to the corresponding to the polar coordinates, and z is the same analogous with the Cartesian coordinate. So r is used to denote the normal polar coordinates, and theta is the angle between the x axis and with the position vector of p, and this is known as the azimuthal angle and is measured in radians, and z is the represents the third cylindrical coordinates. So it is the same as the z Cartesian coordinate and denotes the sine distance of p to the xy plane. So the cylindrical coordinates of p are r theta z, and the relation between r theta z with the xyz, that is x is equal to r cos theta, y is equal to r sin theta, that is same with the polar coordinates, and z of the cylindrical coordinate is equal to the z of the Cartesian coordinate. The third coordinate system we will discuss, that is 3D polar coordinates or spherical polar coordinates. So it has three parameters: distance from origin and two angles, that is r, theta and phi. So here p is the position particle of the position, that is for a Cartesian coordinates it is x, y, z, and for spherical polar coordinates this is called r theta phi. So r is the distance from the origin. So if we draw here one sphere, so r is the distance from the origin and also the radius of the sphere, and theta is the reference angle from the z axis, and phi is the reference angle from xy plane in the counter exposition. So here this is the theta, so the z is equal to r cos theta, and if we draw the perpendicular projection in the z axis, so this zp is equal to r sin theta, that is called rho. So if we take the projection of this zp along this xy plane, so this is also rho, that means r sin theta. So this rho is making with the x axis a phi angle in the anti-clockwise direction. So the x is equal to rho cos phi and y is equal to rho, x is equal to rho cos phi, y is equal to rho sin phi. So what is x? X is equal to rho cos phi and rho is the r sin theta. So x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. One interesting thing is that if you take x square plus y square plus z square, then it is equal to the r square. So this is the equation of sphere. So today we have discussed the three important coordinate system and their relations with the Cartesian coordinate system. Thank you all.